Welcome to episode 43 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes the object so scientifically important. So, I will now run the random number generator.
Floppy gets.
The random number generator has returned the coordinates of 2 hours, 41 minutes, 46.5 seconds for ascension, and -8 degrees, 24 minutes, 8 seconds declination. These coordinates point to the galaxy NGC 1052-DF2, which is located at a distance of about 61 million light-years, or 18.65 megaparsecs, in the constellation Cetus. The galaxy is located within the NGC 1052 group, which is where the NGC 1052 part of the name comes from. While I think the DF2 part of the name is supposed to indicate that this was the second of a series of faint galaxies located within that group that was imaged in the survey using the Dragonfly telephoto array. The NGC 1052 group itself is named after its largest and brightest galaxy, which is an elliptical galaxy called NGC 1052. Unfortunately, having one galaxy named NGC 1052-DF2, another galaxy just named NGC 1052, and a group called the NGC 1052 group could be a little confusing. But fortunately, I don't need to name the other two objects very often. I can just focus on NGC 1052-DF2. So, back to that galaxy. Although NGC 1052-DF2 is not that far from Earth in relative terms, it was only discovered around the year 2000, and that's because it is one of a relatively newly defined class of faint galaxies called ultra-diffuse galaxies. These are ellipsoidal galaxies that are similar in size to the Milky Way or other spiral galaxies in terms of their diameters, but that contain about as many stars as are found in dwarf galaxies. In the case of NGC 1052-DF2 specifically, it contains about 200 million stars, or more accurately a mass of stars equivalent to 200 million times the mass of the Sun, within a diameter of about 50,000 light-years. For comparison, the Milky Way contains about 100 billion stars within a diameter of about 100,000 light-years, or in other words, NGC 1052-DF2 contains 500 times fewer stars than the Milky Way, even though it is only half as wide. Because it contains so few stars, spread over such a broad area, NGC 1052-DF2 looks like a very faint, hazy oval patch in the sky, even when imaged by professional telescopes. What's really freaky is that, if you look at the Hubble Space Telescope image of this galaxy, you can actually see other more distant galaxies on the other side. Normal elliptical galaxies that have the same diameter as NGC 1052-DF2 have such a large number of stars packed so close together that they outshine the other galaxies behind them, so NGC 1052-DF2 looks really weird to me in comparison. However, this is not what astronomers find to be the most interesting thing about NGC 1052-DF2. No, what astronomers find really interesting about this galaxy is that it may contain virtually no dark matter whatsoever. I'm sure a lot of people who follow astronomy or science fiction have probably heard about dark matter at some point. This is basically matter that neither absorbs nor emits any form of electromagnetic radiation. Just to be clear, dark matter is not just material in space that we can't see in the visible part of the electromagnetic spectrum. We also can't see it in radio waves, microwaves, infrared light, ultraviolet light, X-rays, or gamma rays. We only know that galaxies contain dark matter by watching how stars and interstellar gas orbit the galaxies. By looking at the redshifting and blue shifting of light from stars and gas clouds as they move towards or away from us, We can measure the velocities of those things, and we generally find that everything is moving so fast that the galaxies would basically fly apart if they did not contain extra dark matter that produces extra gravitational forces to keep everything together. For the past few decades, virtually everyone in professional astronomy has accepted that all galaxies contain this type of dark matter. Or maybe I should say that almost all galaxies contain dark matter because NGC 1052-DF2 is apparently an exception. A couple of years ago, a group of astronomers led by Peter van Dokkum decided to look at how star clusters orbit this galaxy, and they published a paper in 2018 where they stated that the clusters orbit the galaxy sufficiently slowly that NGC 1052-DF2 might contain no dark matter whatsoever. The stars that are visible in the astronomical images produce enough gravitational force to hold the galaxy together by themselves. This claim was very controversial. It basically led to this inane argument about whether something that we cannot see actually is not there in the first place. If you go look at the science publications about this galaxy, you will see a bunch of papers claiming that if you analyze the data correctly or look at the galaxy in such and such a way, dark matter is actually present, and then you'll see a bunch of other papers with rebuttals claiming that those other people's analyses have mistakes in them, or papers stating that if you look at some new data or analyze the data in a new way, the galaxy actually still contains no dark matter. One person very confusingly first published a paper casting doubt on the claims that NGC 1052-DF2 contained no dark matter, and then published another paper explaining how it was possible to actually remove the dark matter from this galaxy in the first place. Anyhow, if NGC 1052-DF2 actually contains no dark matter, then the interesting question is, how did it get this way? We still find that most other galaxies need to contain dark matter or else they would fly apart. That hasn't changed. Something special had to happen to NGC 1052-DF2 to make it different from everything else. One proposal is that NGC 1052-DF2 gravitationally interacted with other galaxies within its group, including the elliptical galaxy NGC 1052, and that these gravitational interactions stripped the dark matter away from NGC 1052-DF2, leaving just the stars. Another explanation is that NGC 1052-DF2 formed when two dwarf galaxies collided at really high speeds, resulting in the dark matter getting separated from the stars, and these stars getting scattered over a really broad spherical area that looks like the galaxy that we see today. It's still not entirely clear what happened to NGC 1052-DF2, and astronomers are going to be spending much more time trying to understand exactly what happened to this galaxy. You could say that NGC 1052-DF2 really matters a lot to astronomers. Okay, that was a really bad joke. Please don't send too much negative feedback. Anyway, the location on the Earth's surface corresponding to the position of NGC 1052-DF2 on the sky is slightly less than 90 kilometers southeast of Mafia Island off the coast of Tanzania. So yes, there is an island actually called Mafia Island, and I'm pretty sure it has nothing to do with Italian mobsters. What's really interesting about Mafia Island, though, is that it looks like it's a really great place to go snorkeling and scuba diving, and it's actually very well known for its whale sharks. How you can actually relate this fact to NGC 1052-DF2 isn't really clear to me. The website for this podcast is www.randomastronomicalobject.com. You can visit the website to download episodes of the show, read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. You can also find this podcast on Facebook and Twitter. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, which is distributed by filmmusic.io under CC 4.0 attribution license. The sound effects are from the Freesound Project at www.freesound.org. Thanks for listening.